I'm Patrick Hutchinson, Global Modernization Leader for CI&T. And in this demo, we're going to be taking a look at how we combine the power of the CI&T Flow platform, agentic coding tools, and industry-leading software systems as an orchestrated modernization pipeline. We've found that this system and overall approach that leverages the best available tools and integrates human expertise and judgment in a transparent and cohesive workflow is the key to achieving successful modernization outcomes in the real world, where the code is messy and undocumented, the end state is hazy, and the path to get there is winding and treacherous. In this demo, we're going to be reimagining an example legacy system in the financial services space. The system we're modernizing is the popular card demo application, which is open source and contains about 45,000 lines of COBOL code. The screen you're seeing is the account management interface, and if all goes according to plan, we'll have a new implementation of this screen by the end of the demo. Our goal here isn't to just lift and shift this onto a new tech stack. We're reimagining these business capabilities in a modern architecture. So the same business rules and core functionality with a new user experience and technical foundation. In our case, we're moving the application to Java and TypeScript, but this is just an example. The target could really be any modern stack. One quick note before we get started. Some of the agentic processing is sped up just for the sake of not boring you to death. In real time, every step you'll see took about 45 minutes, with over 30 minutes of that occurring during the one-time initial documentation step, which is coincidentally what we'll take a look at right now. We're going to use AWS Transform as our tool for deep reverse engineering here. Transform reads through the entire legacy code base, potentially millions of lines of code, and generates comprehensive documentation. The primary use case for Transform is to handle end-to-end modernization, where the goal is to keep the functionality the same, but re-implement the exact same system in a new language or architecture. In cases like this, where we're reimagining the application, the output gives us business rules, technical requirements, and a detailed understanding of what the legacy system actually does, which is likely going to be much more in-depth than what anyone on the current team can actually articulate. This documentation becomes our requirements foundation, but it's important that these outputs need to be reviewed by your stakeholders. So we're not just blindly pulling everything forward. This is a chance to decide what you actually want in the modern system and what adjustments to make from the legacy system. Now we shift from understanding the legacy system to envisioning the modern one. This is the reimagine part, where we enable the same business capabilities, but using a modern approach. We'll start here by creating a new epic in our Jira project, and the agentic bus, which is part of CI&T's Flow platform, orchestrates a series of specialized agents running on Amazon Kiro to accomplish this business capability extraction. This process uses the source code as well as documentation from the previous step as context. The agents generate a new list of epics centered around business capabilities, not technical components. So we're not talking about databases and APIs yet. We're saying this capability exists in the legacy system, and we want it in the modern one. We're directly populating Jira with the results so that project stakeholders can easily make adjustments as needed. Our next step is to use the same orchestration framework to plan the implementation. Again, this is triggered from Jira by moving an epic into the planning status, which automatically kicks off the planning process for that specific epic. This could be done for the whole project at once, but we found that focusing on a few epics at a time prevents the team and stakeholders from getting overwhelmed with the amount of new information. The epic is planned out as a set of user stories that will implement all of the capabilities identified in the epic. User stories are still written from a user's perspective, not a technical one. So they reference specific business rules from the legacy system and call out dependencies between stories, but we're not getting into implementation details just yet. The agent creates the user stories, and the orchestration framework populates stories directly into Jira as the system of record. It also provides guidance on implementation order and dependencies that help with planning. The expectation is that your team reviews, modifies, and prioritizes these stories. The AI does the heavy lifting of drafting, leaving human experts to make key decisions. Now, we're going to start with the specification of a particular user story. Again, triggered by a Jira status change and integrated with the CI&T Flow Agentic Bus, which serves as our orchestration framework. We can see from the status of other stories in this epic that we're partway through our modernization project. And here, we're going to finish up this epic by implementing the last remaining user story. We use an approach called spec-driven development to drive quality and adherence to standards in the generated code. Instead of asking AI to just write the code, we first have it create a detailed specification that includes every dependency, every file to create, specific algorithms and business rules, all spelled out in detail. There's a well-known principle in software that the cost of fixing errors grows exponentially the further downstream you get. AI hasn't changed that. So if we catch issues in the spec, that's a quick edit. Catching them in code is much more expensive. The spec appears as a pull request in GitHub, where the team can review it, make edits directly in the GitHub UI, and approve it just like they would any other code review. Next, we'll merge this PR, which automatically kicks off the development agent. That's the handoff from spec to implementation, and it's all fully automated with no wait time. So now we merge the pull request with the spec, which is going to automatically kick off our modernization developer agent. This agent takes the spec along with project level steering documents that define coding and architectural standards, and then implements the user story, including unit and integration tests. Like the other agents in this workflow, the orchestrator is leveraging the Kiro CLI as the agentic framework. One really nice feature about Kiro is that it's able to dynamically load steering documents based on the current task. So we can pull in details about the modern front-end implementation without cluttering up the context window. While we're waiting on our modernization developer agent, let's take a quick look at the generated code and the running modern application in its current state. We have working authentication, a dashboard with some placeholders, user management, and most of our account management capability. We're just missing the account details page, which is being built by our agent as we speak. While our modernization developer agent is finishing up, I just have one additional point I'd like to make. We implemented the agentic bus to be extensible and flexible. So each agent in the pipeline can run on a different platform. Some agents could use Kiro, others Claude Code, others could use open source or even proprietary tools. Additionally, in this example, we've been using Jira and GitHub as our issue tracker and source repository, but those tools are flexible as well. The modernization pipeline itself is even a customizable workflow. So if we wanted to have additional agents, a different set of steps, or change the level of granularity in which individual agents execute, that's all customizable. The idea is we wanted to create a framework to adapt to the situation and not the other way around. When the developer agent finishes its work, it creates a pull request, just like the technical planner agent that created the spec. The team can review the pull request, make edits, and push additional changes, just like when collaborating with a human developer. Our steering files are explicit about creating unit tests, along with any code changes, so we see those unit tests included in the PR as well. When we merge the pull request, the orchestrator sees this and automatically updates the status on the corresponding Jira ticket. In a real project, this would feed into automated builds and deployments and test suites, but for this demo, I'll just pull the changes manually. Our application supports hot reloads in development mode, So we can simply click on one of the accounts and now see our new account details page that was just implemented by the developer agent.